Hello everybody, first of all welcome to KML. So I am your physics lecturer. My name is Miss Grace. So today we will be entering chapter 1. So basically I will be trying to finish up our chapter 1 for this first week lah. Okay, so chapter 1 is on physical quantities and measurements. So there's only 2 subtopics in this chapter and it's a very short chapter lah. Okay, so the first for the first subtopic is on dimensions of physical quantities. So in this subtopic, you have to be able to define what is dimension, determine the dimensions of derived quantities, and lastly, verify the homogeneity of equations using what we call as dimensional analysis lah. Okay, so dimension, it is defined as a method used to describe a physical quantity in terms of its basic quantity regardless of the system of the units used lah. So the symbols that we are going to be focusing on are length, mass, and time. And we are going to use what we call as the square bracket to denote that it is the dimension of a physical quantity lah. For example, for length, it is going to be L, mass capital M, time capital T. So note that there are 2 types of quantities. The first one is basic quantity and the second one is derived quantity lah. Okay, so basic quantity is a quantity that cannot be derived in terms of other physical quantity, and derived quantity pula, it is a quantity that is derived from these base quantities. Okay, so some of the dimensions of these basic quantities and physical quantities are shown in this table here. So basic quantity, length, mass, time, electric current, temperature, amount of substance, luminous intensity are some of the examples for basic quantities. So these are the SI unit and the symbol lah. Okay, so remember for our syllabus we are only going to be focusing on these 3 here lah: length, mass, and time. And then physical quantity pula, velocity, volume, acceleration, density, momentum, force, and work are some of the physical quantities, and this formula here is important for us to do dimensional analysis lah. Okay, so if you do not know the formula, you won't be able to do the dimensional analysis lah. Alright, so now we are gonna go into prefixes. So remember, I think you've learned this in your SPM lah. So this is used to represent larger and smaller values. I don't have any problem with how you are gonna solve ataupun how you are gonna convert units. Just make sure you don't do any silly mistakes lah. Okay, so a simple way of converting units of measurement is basically if you want to convert a smaller unit to a larger unit, you are gonna divide it, and vice versa lah. Right, so let's look onto example number 1. So this is 580 meter into kilometers. So this is from a smaller to a larger unit. So you're gonna do this by dividing it with 1,000 kilometer lah. 1,000 meters, sorry. So kilo is times 10 to the power of 3 lah. It's this one here. So you will get 0.58 meter as the answer. And then do it your way. I don't mind if you write it as 1,000 pun tidak masalah, as long as you know how to convert units lah. So 11 meter to centimeter pula, we are gonna multiply it with centi. So you will get 1110 centimeter. Okay, so for question C pula, so a lot of students make mistake at this part because they always forget to include the square at the meter square. Okay, so we have to convert this by using milli, so that is times 10 to the power of -3. But since this is meter square, you have to multiply it with 2 here, so you will get 4 times 10 -6 meter square. Right, so always remember to include the square lah. Alright. Now let's look onto the dimensional analysis. So this analysis is used to determine the unit of physical quantity, derive mathematical expressions of equation, and lastly, check the correctness of physical equation by what we called as principle of homogeneity. So principle of homogeneity is basically telling us that the dimensions of both sides of the equations are equal. Okay, so it should be the dimension of left hand side and the dimension of right hand side is equal. Okay, so please note that pure numerical factors or numbers like 1 over 2, 3 over 4 ataupun pi do not have any dimensions lah. So this table shows us the rules of dimensions. Okay, so you will understand this part when we're doing this example lah. Okay, I'm just gonna continue straight away. So for speed, let me just open up my other notes so that I know I am doing it correctly. Okay, all right. So speed is also, what I'm trying to say is speed is a, okay, I can't, okay, never mind. Okay, so we know that speed is equal to distance divided by time, right? So we know that distance, dia punya dimension is equal to L divided by the time. Okay, so anything that is okay, so distance, we can relate it with length. Okay, that's why we are putting it as L as the dimension. Okay, it's about length, it's about how far is it. Okay, so that's why we are going to use L. So from here we are going to get L T negative 1. Sorry, I think I'm just going to put this like that. Okay, so from here we know that L is equal to M, T is second. So that is how you get the SI unit and the dimension. This is the dimension, this is the SI unit lah. Alright, and then acceleration. So we know that acceleration is equal to velocity divided by time. So velocity is the same as distance over time. So you're gonna get distance over time lagi. Okay, so if you get time and time as the denominator, you are just gonna put it as distance divided by time square. Okay, so from here we know that distance is L, T, time is T, so this is gonna be L T negative 2, which gives us ms negative 2. Alright, okay, force pula, force is equal to mass times acceleration. ACC is acceleration. So from here we know that mass is just mass times it with acceleration. So acceleration is the one we've obtained here, so that is distance divided by time, square it, and we'll obtain as, we'll do it as m, distance is L, so you have T at the bottom, so this is M L T negative 2, so this is kilogram meter second negative 2. Alright, okay, now lastly we not last, and then we have torque. So torque is equal to force times dengan distance, and we've obtained force, which is this one here, so that is mass times distance over time times it again with distance. So this one will get mass, sorry we forgot square here. Okay, so this one's gonna be mass times distance, so we square this and divide by time, square this again, so we'll get mass, distance is L, we have time square as well. So this is gonna be M L T negative 2. Okay, so this is kilogram meter square second negative 2. Okay, so if you just want to directly end this here and directly write this one, tidak masalah juga, boleh juga macam tu. Okay, and then we have power. So power is equal to work divided by time. Okay, and then work is equal to force times dengan displacement divided by time. So force is mass times distance divided by square the time times lagi dengan the displacement divide lagi dengan the time. Okay, so from here, if we try to simplify this, we'll have mass times distance, square it, because we have distance and displacement, they have the same dimension, divide it with time cube. Okay, so we have mass distance as square divided by time as cube. So this one is just gonna directly write it as kilogram meter square per cubic. Okay, all right, so that is how you do the dimensional analysis for all 5 of this lah. All right, so that is the end of our first subtopic.